Thank you everyone for joining this vodka. And before we start the infrastructure testing, so here we have our speaker for today, Ayushi, Arora, lovely Munjal, myself, Mohit, Kumar, and Shalika Singhal. You will get introduced by each of the speaker when they start speaking during this session. Hope you can hear me loud and my screen is also visible.
Yeah,
Thanks. Okay, so here's the content we are going to serve today. So it's about infrastructure testing. It's very important to understand the basics of infrastructure testing before we start planning our test strategy for infra. And why are we doing infrastructure testing and when to perform the infrastructure testing? It depends on the project also, but there is a general approach also that we can follow. So there are various tools available in the market for infrastructure as code, for configurations. We will explain each and everything. And then followed by that, we will have a demo session. We are taking one of the tool Inspec for testing. And second, we will use another tool, another library you can say that is provided by Azure. And at the end we will compare also, like for your project or for your whatever you are doing right now, what you can choose, how you can choose a tool or library for your infrastructure testing. And has anyone worked on infrastructure testing before? Please ping us in the chat, or you can ask anything in the Q&A. Okay, so first of all, let's understand what is infrastructure. So you can relate it with your own project also in your current organization, even if you are not working, but still you can relate what is infrastructure. So in infrastructure, let's have some basic components like database, data centers, servers. We all see these components as mandatory component in every infrastructure project. Other than that, we have various load balancer, routers, switches, network component, and other software components also, like storage, middleware, messaging, queuing. All these components we see in our infrastructure. And some of these are hardware components, some of these are softwareable, configurable components. So these all components together make your infrastructure on which you deploy your code and applications start running. So these are just basic components. And right now, we are quite advanced in terms of infrastructure. Like it's not like we are configuring any server or any hardware machine remotely manually. It's like everything is automatic. We are just writing our code on machine, like developers write the application code. So similarly, we are writing our infrastructure code also, and we are deploying that code on the machine that is configuring or deploying our application on particular infrastructure. So you can see in the diagram, developers can, or even QAs can also push the code, and it will be the part of CI/CD process, like continuous integration, continuous deployment, and then it will configure few machines or a few servers in the cloud. So with the code, with the help of code, you can configure your machine remotely, or you can create resources remotely. And resource can be anything that we saw in the first slide, like it can be any database, data center, server, or any load balancer, anything else. So advantage we get is with infrastructure as code, we don't need to take care of any hardware devices and all. So because in most of the project we see hardware devices and all, these are provided by our infrastructure providers that we call nowadays cloud providers, that we will see in the upcoming slides. So developers can focus on the coding part, and whether it's application code or infrastructure code, it will go through the same pipeline, or you can say any tool like Jenkins. So this is all about infrastructure as code. And once we have the code, then of course testing is required, because if there is a code, then there can be bug in the code as well. So that's why testing is very important in nowadays in the project for infrastructure. But what else you can test? So first of all, there are various cloud providers like AWS, Azure, Google Cloud Provider, and they provide some libraries. You can write your code in any language, like AWS provide their own library, cloud formation, and you can write code in any language like C Sharp, .NET, Java or JavaScript. And based on those languages, you can write your own test, like you can unit test your infrastructure code as well. But mostly these libraries are provided by the cloud service providers. So to test those code, you will rely on the cloud service provider libraries and all. Similarly, we have different tools like Terraform, Chef, Puppet. So those tools also provide few libraries, and you can use those library for testing of the infrastructure code. So the first point you see is the lowest level of infrastructure code and test. Second, you can test around the containers as well. For example, you are deploying some artifact on those machines, and before deploying the artifact and containers and all, you can write test around that, because let's say your server is up, but once you deploy the container or artifact, it can start failing. So on the local machine or even the pipeline before deployment, if you want to test something, you can test around those containers or artifact also. So this is quite common type of test, and we are going to cover this testing around containers and all in this talk. And third, we have, let's say you have the server up. I mean, machine actually is running in your remote environment. That can be any AWS machine or Azure machine or any service provider machine. Can be your in-house infrastructure machine also. Let's say that machine is running, and you want to check the configuration of that machine. And configuration can be in anything, like it can be any networking configuration, it can be any software configuration, it can be related to security, VPC, or anything you see in the server that can be configured. So that testing is quite important, like, because it is, if it is not configured properly, then even if you deploy the correct artifact, still your application will have the failures. So this type of testing also we are going to cover in this talk, testing around the configuration. And other than that, testing can be around the hardware devices also. Like we have various load balancers, routers, switches. These are hardware components, and sort of testing is required for these components also. But for today's talk, we are not going to cover these things. This is sometimes can be part of hardware testing and networking testing. So that is, you can say, out of scope for this talk. And other than that, you can test something from security perspective also. You can check the performance of the infrastructure also. There are a lot of different types of test even in the infrastructure test. But for today's talk, we will cover mostly second and third point, that is testing around artifacts, containers, and second testing around the configurations of servers and all, and little bit about the security also. Hope it is clear. If you have any question, please drop in Q&A. And even not only me, anyone can answer in the panelist. Okay, so once we know what is infrastructure testing, but still it is difficult to convince your team why we are doing the infrastructure testing. Once we have the solid reason, then we can convince our team also. Like in our team, we have various leads, managers, and developers. If you know the reason, then you can convince. So let's see few examples of infrastructure failures. So here you see the peak HSBC Bank. Here in 2016, they have major IT outage, and lot of customers, bank customers were impacted. They were unable to access their account online. And you can see by such failures, it will not only harm the like the revenue, and it will be impact the customer also. It will impact the reputation of any company in the market. So this kind of failure we recently we saw in AWS also. AWS also has infrastructure failure, and because of that, even their monitoring part was also running on same infrastructure services. So that's why, because of their failure, they were unable to check their monitoring part also. So you can also relate with your own project also, how you are doing the monitoring of your project. How is the response and all these times. If you are running monitoring on the same server that is running the application, and let's say that server is down, even then you cannot figure out what's going on. Like you cannot check uh, when your service was down, because monitoring will also be down if it is running on the same server. So same happened with the AWS also. And a lot of other examples we see, like this is also the one of the airline um, software were not working because of infra failure, and because of that there a lot of flights and all were cancelled or delayed. So you can see, you can even guess like how much loss it can be for the companies and their reputation, and for the clients and customer also. So that's why even infrastructure failure are not like it's everyday failure, but whenever it happens, it will impact a lot. So that's why infrastructure testing is important. I can see few questions in Q&A, but somehow I'm unable to open that.
No worries, lovely. We are taking care of
Okay,
those
and
Q&A.
okay, thank you, Anshul. So once you understand the infrastructure testing and you start doing the infrastructure testing, what benefit you get? Your service quality will improve, and because you will have quite stable environment, you can avoid the risk of any financial loss or any operational cost. You can avoid that, and with the good practice of infrastructure testing, you can even improve the time to market also, like your product can be launched in the market quickly also. We will see how to when to do the infrastructure testing in upcoming slides. And also once you have the testing in place, whenever any accident occur, like whenever any infrastructure failure occur, you will be aware like where can be the what can be the issue, and you can fix that quickly, because you can see what type of test can fail and what type of tests are missing. So you can easily figure out the loophole in the failure. So like we discussed in the beginning also, there are a lot of cloud service providers and lot of configurations tools in the market. So for few type of testing, you need to rely on your service provider. Like if you are using AWS and if you want to test something, few type of testing you can do even with any tool like Inspec that we are going to show. But for few type of testing, maybe these tools can provide the better library for you to test. So it depends on your project also, like what type of cloud provider tool you are using. And these cloud provider provide you the remote machines and that can be run with minimal configuration. So that's why people use these services, and they don't rely on their own server that are very difficult to manage and configure. If we talk about like 10 years prior to this, like we can have many projects that are running on the in premises, like in their own premises infrastructure. But right now a lot of projects are moving to external cloud providers because they provide better services and their uptime is really high. Like um, it depends on the service provider, but it's more than 99.99. Once you start the testing, you can consider that factor, which cloud service provider you are using. And sometimes we don't use any particular cloud service provider, but we use any configuration tool like Terraform. And because the advantage with this configuration tool you get is these tools can talk to any service provider like AWS, Azure with their APIs. And sometimes people prefer using these tools in their infrastructure. Like Terraform is one of the famous tool. You can write your own infrastructure code in HashiCorp language, like HCL language. And these tools provide the advantage that these tools also provide some testing libraries and tools. Like for today we are going to cover Inspec, that is provided by Chef is another configuration tool. So we are going to use Inspec, that is an open source tool by Chef. So here also you can relate with your own project, what you're using in your own project. Similarly, you can decide the tools and libraries that can help you in the testing. Yeah. So now question arise, when to do infrastructure testing? Like, so basically we believe in shift left approach. So what this approach says, like to manage the software testing and to start the software testing in the early phase. Like whenever you are building any application, you are building the infrastructure. Similarly, at that time you can start creating or start maintaining your infrastructure test. So it's not about you have to first wait for the development, then it will have some bug, and then you will create some automation test. So testing approach can be bug to eliminate the bug in the early life cycle. We can start the testing also immediately, so that we call shift left testing. And not only infrastructure, we follow it in the functional and other non-functional testing also. But for infrastructure also, this is also suitable, that we are doing in few projects in ThoughtWorks also. Yeah, I guess we have covered almost everything about the basics of infrastructure testing. Any questions, anything, you can ping us in the Q&A. So next part is Inspec, that we will show the demo. Shalika will present that topic. Shalika, over to you. You can share your screen.
Thanks, Lovely, for the wonderful introduction to infrastructure testing. And I hope my screen is visible and
Yes.
my voice is audible. Okay. So, hello everyone, myself Shalika Singhal, and I have been associated to ThoughtWorks for 1.5 years, having overall 5+ years of experience and working as a quality analyst in ThoughtWorks. So, Lovely has talked about infrastructure testing, and now we will be exploring one of the infrastructure testing tool, which is Inspec. And before just moving to the Inspec demo in the tool, let's just briefly talk about the agenda that we're going to talk about in Inspec. So we will be discussing about the Inspec introduction and like what is Inspec in brief, and then why we have chosen Inspec. Then we will be talking about the Inspec glossary, which is the Inspec syntax that we are going to use. Then we will be demonstrating one of the Inspec tests and the report format that it provides. Post that, we will be talking about containers and Docker basics in brief, because they are vast topic in their self, and we will be just focusing about them as per their only introduction or in brief, because we will be using containers to run our Inspec test. So let's move to Inspec. Inspec development is supported by Chef Software Incorporation. So what is Chef? Chef is a configuration management tool that uses Ruby. It is designed to deploy, configure, and manage servers. And Inspec is a tool through which we can do application testing, infrastructure testing, and compliance testing. We will be soon demonstrating the examples of both infrastructure and compliance testing. So how Inspec works is it actually declares the expectation of the system, and then it fetch the snapshot of the actual system state, and it compares both of them, and then it displays the findings in a form of report or in console, and then we can easily take actions upon them. Inspec syntax is very human and machine readable format. It is very simple. Even if we don't know Ruby, we can still start working to write Inspec test. And Inspec language is built up from simple resources. So what are resources? We will be covering them soon. But Inspec language is built up from simple resources that can test everything from testing files on a server on your local host to testing files over SSH, or files or any infrastructure related activity on cloud. So why we have chosen Inspec? Because first of all, it's open source. Its development is supported by Chef Software Incorporation. It has awesome community support. So Chef Slack's Inspec channel is available, and we can like or anyway anytime ask a question, and the code developer usually responds within no time. It is resource rich. So I'll quickly show you what do I mean by resource rich also. So resources are your category or your target system, your platform where you are actually testing your infrastructure on. And we can see that Inspec provides us more than 80 plus of resources. And the list is going on. These are the resources that Inspec provide us. Just to give you all a glimpse of the powerful resources that Inspec provide us: AWS, Azure, Windows, OS, Linux, and whatnot. It can run anywhere from your local system, as I said earlier, to file to your containers, to cloud, and it also supports multiple operating systems. Now let's just talk about Inspec DSL. So DSL is an acronym for domain specific language. So what do I mean by Inspec DSL? DSL basically provides your control to write test in Inspec without actually knowing about the Ruby language. So even if you're not aware of the Ruby language syntax, using Inspec DSL, we can straight away start writing a test. And that keywords that it provides us are describe, it, its, and the matchers. We will be soon talking about them. So let's just talk about each one of them one by one. So this is a simple control, and control is nothing but a group of tests. So these are your tests, and usually we write test with it or its. Now, what is the difference between it and its? So using it, we will be verifying the resource itself, and using its, we will be verifying its properties. So in Inspect, we usually express the expectation in the form of properties or condition, and then we use matchers to perform assertions. Resource, as I said earlier, is the category or target system. In this basic example, we have taken it to be a file, but soon we will be seeing that it can be your Docker, it can be a cloud provider, or it can be any other platform that needs to be tested. And in fact, we can create a custom resources also. Then we have the resource parameter. Now, resource parameter are the information that a resource want. For example, in this case, resource is a file, and we are specifying the file path in the resource parameter. Now, test start with it or its. As I told you earlier, it can be used to verify the resource, and its are used to verify the properties of a resource. And then we have matchers. For example, should is a matcher, should not is another matcher. We have equal, compare, and so on. And we usually write all the tests inside a describe block. And then this is a simple control. So we have now talked about the Inspec DSL. Let's just quickly see a demo of the Inspec test. But before moving on to that, I would like to, just a second, there is an issue in screen sharing. Yes, so I would like to give a brief introduction of this Inspec Infra Test repo that we will be sharing with you all. And we have intentionally created it in coherence with our day-to-day functional test framework. So usually we have this package where we have our source code, and then we have a package where we have our test, we have our functional, non-functional test, and in a similar fashion, we can keep our infrastructure test also over there. So we have kept few examples of infrastructure test and categorized them into various configuration, for example, containers, files, and image tests. So this is the repo that we will be sharing with you all soon. And it has the documentation and the commands that we use to install Inspec on various OS, and the commands that we will be using throughout a demo. So let's just see our demo of the Inspec test. So we will be testing a file resource. So what are we going to test inside a file report? Let's just see that. So this is the file test, in which we are just specifying the path to a file. So this is the file which is there in the project itself, and we are going to just test this file. So why do we need file test? We can use file test to test all the system file types that we have, including files, directories, symbolic links, or any other thing. And using file resources, we can verify the permission, the mode, the owner, the size, type of properties of a particular file. So here we have specified the file as a resource, and we have selected the path to a file, and then we are verifying that few of its condition that it should not be a directory, and then we are verifying that its properties such as group and owner should be staff and root. So now let's just run the inspect test, and I hope my terminal is visible. So I'm about to write the command which we use to run the inspect test, which is as simple as inspect exec, which is execute, and then the path to your test file. So we have this test inside the test folder, inside the file test, and the tests are saved with file test.rb command. So I'm going to execute this file test, and let's see what result does it display. So it will tell us whether the assertions that we have written over here match the actual declaration or not. So these are our expectation, as I've said earlier. And now it is going to check the properties, the type of this first file, and it is going to check that whether our declared expectation match the actual results or not. So over here, we can see that our assertions are passed. Let's just see an example of failure in which I have intentionally changed the owner of this file. And now if I just execute this file again, so this test should fail. and it should highlight me that the expectation of owner is not same as it is declared. So we have seen that a test failed gracefully, and it has displayed us the result in the console itself. So this was our first demo of the first test that we have used in Inspec. Now, what if we want to run the test inside a CI/CD pipeline, or we want the output to be in a report? Inspec provide you that capability also by just passing a reporter flag and then specifying the type in which you want output. So I want output in HTML format, and we can specify the JSON, YAML, and any other format that we want. And then the name of the file. So for example, I have specified index.html. So if I show you over here in my repo, I don't have any index.html as file. And when I just execute this command, it is going to run the test against the actual state of the system. And then it is going to store or redirect the output to this index.html file. And we'll see that this new file is created. So if we just open that file, we can see the test that is executed, pass test, failed test, the time it has taken to execute that test, and the assertion like what the test has got and what was expected. So this was part of the test report that I just talked about. And using the reporter flag, we can also pass JSON or any other unit through which we want the report in any format. Now let's just talk about inspection. So till now we were writing test. We were writing test inside a file, and then we were saving that file in .rb format. But what if we don't want to write test inside a file, and instead we just want to straight away write the test in a shell? So Inspec provides us that capability, and it provides us that interactive session through which we can just practice the Inspec DSL, its resources. We can just execute any test to see whether the result are passed or not through Inspec shell. So how to initiate the Inspec shell? We can just simply write Inspec and then the shell, and okay, I have made a typo. And it will initiate an interactive shell, which is an Inspec shell. And in this Inspec shell, we can write the test straight away. So let us just explore one of the tests. To save the time, we have already noted down all the tests that we will be using in this demo. And over here, for a demo purpose, we have specifically used this package resource to verify Git. So over here in my local system, Git is installed. In real scenarios, we can use any package that is installed in the infrastructure, be it be Java, .NET, Tomcat, any package that we want to verify. So over here, I have just arbitrarily chosen Git, and I'm just verifying that whether it should be installed or not, whether its version should be 2.2.7 or not. And then let's just wait to see what is the output of this Inspec shell command. So it has said that the package is installed and its version is 2.2.7.0. Now let's just change the package version. Say 2.2.7.1, and then just verify it. It should let us know that the version expected is not what it got, and we got the output in the console itself. So over here, we were writing the test in with break lines, like we were writing part of a test in one line, then another part of a test in another line. If we want to write all the tests in a single line, we can use the -c flag provided by the Inspec to write the test. So till now, we have talked about the Inspec, but before Inspec and Inspec shell, but before moving to the next round of tests that we're going to demonstrate on containers, I would like to throw a poll to see what people have understood from Inspec. And I'm launching a poll with request you all to please vote, like what have you understood from Inspec. And for any questions, please feel free to post them in the Q&A section, and we will be taking them along. So yes, I'm getting votes that it is used for both. It is used for infrastructure testing, and then majority of people are voting for both, which is nice. Okay, so I think I'm able to explain what is Inspec. Yes, as correctly voted by 33 people. It is used for both infrastructure and compliance testing. Thank you for the voting, folks. Let's just move to the container-based virtualization. So we have just now shown an example in which we were running the inspect test onto the local host. But we have seen scenarios over where our application may perfectly work well in lower environments, but it is not able to work well into the higher environments. And the reasons are because of the binaries or libraries. So it may have happened a scenario where we have tested our application with say Python 2.7 version in the lower environments, and then we are running our application with Python 3 version in higher environments. So weird things will happen. So now how Docker will solve this problem? So Docker consists of the entire runtime application. So the application, its binaries, its library, its configuration files, and the dependencies are bundled into one package. And by containerizing the application and the dependencies, difference into the OS and the underlying infrastructure are abstracted away. So this is the example in which we are running containers, 3 containers in one infrastructure. So we are just talking about containers in a very brief because they are a vast topic in itself, and we will be just showing few inspect tests on containers. And for the beginners over here who don't know containers, we are just telling containers in brief. And container facilitate fast and rapid agile development. The faster we move, the better our infrastructure needs to be. Inspect provides us that capability by testing the infrastructure. Since Docker is the widely used platform for managing the containers, we will be using Docker only as a platform over here to spin up the container. And don't worry, we don't need to know the very hardcore things about Docker over here. Only the basic of Docker that I'm going to tell over here, and then we're going to run and see that we will be creating an image. We will be creating a container using a Docker file, and then we will be running the inspect test on those. So just 3 basic commands that we should know over here are Docker file, Docker image, and Docker container. So what is a Docker file? Docker file is a list of commands that we need for our application to spin up. And when we just build that file, we get a Docker image. And when we run it, we get a Docker container. So if I just quickly show you a basic example of the Docker file. So this is the Docker file that we are using in our demo, and it is containing all the commands that we are using to spin up the container. It is just saying that, okay, just download the OpenJDK image and then copy all the source and backend folder into the Docker container. And then we have intentionally added a health check over here to poll the thoughtworks.com website, and we will be testing that health check test also soon. And then we have an entry point command. Now what is entry point command? So entry point command is used to specify the command that is going to run once we spin up our container. So you see the power from this particular file, as simple as a simple list of commands. We are just spinning up our container, and then we can also push this Docker file to a repo, and then this Docker file again can spin up container in some other machine. What commands we will be using to spin up our container are also listed here, and they will be listed into the repo as well. And we will be showcasing the demo where we will be building our image and we will be running a container, and then few tests that we will be running onto the containers and the image. Let's just move to the demo part. But please feel free to post your questions into the Q&A chat, and panelists will be taking care of that. So I'm now going to build a Docker image from a Docker file. So the syntax for that is as simple as this, that Docker build dot stand for building image from this particular current directory, and we are tagging that image as demo underscore image. So using this command, the Docker file that is stored in a repo, it is going to use that Docker file to build a Docker image. And now we'll just execute this command. So we see that we have built an image, and we can check that by using Docker images, and we'll see that, okay, demo image is built now. And now we will be running a container from that image. The command that we will be using is this, which is nothing but just we are pointing out that, okay, from the demo image, spin up a demo container, spin up a container whose name is demo underscore container. We can like understand Docker file as a file in which we have a source code, and then the Docker container as the execution of a process, because in Docker image and container are exclusive. We can have image, but we cannot run a container without image. So in this, we have run a container with this image, and if we just see the container spin up through Docker ps command, we'll see that we have just spin up a Docker container, which is using this command tail -f. But in our real application, we will be using any command that we require to spin up our application. For a Java based application, we can use a command that will be spinning up our application, Java application, and so on for other criterias. Over here, we have used this tail -f command so that the container is not immediately terminated after getting spin up. So our container and image are there. Let's just see few tests on that. So over here, we saw that for image test Docker file, we have added a health check. Now, what if we want to write a test where we are saying that, okay, your Docker image should has a health check. So we have added that health check over here where we are saying that, okay, check that the demo image should have the health check and it should not be null. So let's just execute this test. And then the image, and inside image test, we have this image health check test.rb, and it will just verify that whether our Docker image has the health check or not, and we see that it is passed. Now, another set of tests can be around the tag or the repo, where we are saying that first of all, the demo image should exist, and then the tag in the repo should be latest and demo underscore image. So why do we need image test? We can need image test when we are not sure that the developers might have accidentally changed the tag or the repo, or the image was not able to get created because of any error into the Docker file. So for that type of scenarios, we might need the image test. So let's just execute this test to see whether the image test has passed or not. So we see that the image test has passed and the repo is expected to be demo underscore image only. Now let's move to the container test. So for the container test, we can see that we are just verifying that first of all, the container should exist, which we have already spin up in this command, where we have run the container from the Docker image file. And now we are verifying that it should be spin up from a particular image, and its command should be this. And when I will run this test should fail because it says that the image that this container is expecting should have latest one as the tag. But we have spin up that image with only latest as the tag. So ideally this test should fail. Let's just execute it to see whether it fails or not, and then we'll be able to understand more how Inspec beautifully finds the violation and displays the result. So it has immediately find out that the image what this container was expecting is not what is this container actually spin up from, and then we have found the violations. So why do we need container test? We can need container test for anything, for checking the image from which it is up, for checking the port, whether particular port is accessible on that container or not, and whether a particular port should be disabled or not at that particular container. So over here, we have intentionally changed the image name, and we see that it is being caught easily by the uh, Inspec. So these were the commands that we have used, and it is also listed inside the infra test report that we will be sharing with you all soon. Implementation part, we have shown few examples. Now let's just talk about the Inspec profiles and controls. So Inspec itself is a very vast topic, and when we dig deep more into it, we'll find that there is a concept of profiles. Now, what are profiles? Profiles are nothing but group of tests. So earlier we have seen an example, a simple control, which was listed by describe block. That was a simple control. And when we group or organize multiple controls, we get multiple controls, we create a profile. So a profile is nothing but a group of tests. A control can also have group of tests. That was a simple test with one describe block, and a control can also have multiple describe block. So Inspec has already been shown that Inspec was used for infrastructure testing, but as mentioned earlier, Inspec was also used for compliance testing. So what is compliance testing? In compliance testing, basically is a conformance testing, is a non-functional testing technique over where we are just verifying that this system developed meets the required standards or not. It is used for regulatory and standard check that whether the system or the environment you are using meets the required rules and regulations or not. So Inspec already have some predefined profiles available into the chef supermarket, and we can use those profile as is to not reinvent the wheel and to not write those tests again and again. So I'll be just demonstrating one of these example where we will be just running the simple Linux baseline test profile against the Docker container which I have spin up, and that will make more sense to understand the compliance testing capability that Inspec provide us. So let's just use this command now. So Inspec is actually using this profile. This is the predefined profile available into the chef supermarket for the Linux baseline compliance testing. And we are using straight away that in a Docker environment. So we will be just checking the Docker ID from which our container is spin up, and this is the container ID. We will be replacing this over here, and T stands for target. So we are verifying that the Docker container that we have spin up meets the basic Linux baseline standards or not using this command. And when we just execute it, we'll get to know the result. And it is just verifying the Linux baseline standards are met against a Docker container or not. And we see that, okay, almost 80% standards are met and 20% standards are not met. So what standards are met, what standards are not met, we can easily see them in the report or onto the console. And depending upon the application or the environment need, we can skip those control for which we don't want those assertions. So these assertions at first glimpse may see to us that are very important and they are not passing, so okay, our compliance testing is failing. But do we actually need those assertions or not is entirely dependent upon the environment on which we are testing. So depending upon our need, we can skip, we can add those control and do the compliance testing. So that was all from the profile and the control parts. Now I'll hand over it to Lovely for inspect test onto the AWS.
Yeah. So before starting that, people are asking a lot of questions, and mostly these are related to when to run these tests. So basically, right now, what we have shown is not the configurations test. These are just like test based on your artifacts or containers. So even you can run it on your local system. You can build your image or containers on the local, and you can test that. Because why this testing is important, because you're going to deploy same artifact or container on the server. So when artifact or container has some issue, then we should not deploy that same on the server or any remote machine. And even not only on local, you can run it on in your pipeline as well. Let's say you can have any Jenkins stage just before the deployment or before the any integration test. You can just create a stage that will run all the inspect test. Okay, let me share my screen for cloud resources test. So Inspect provide a lot of resources, not only the Docker resources and file resources. It has a large list of resources. Let's say you have used AWS or Azure service provider, cloud service provider in your project. You can run the test against those service provider as well, because Inspect basically use the API, and whatever the resource or whatever the remote machine or load balancer, whatever you have created on any cloud service provider, Inspec will use those APIs provided by the cloud provider, and by the API Inspec can get any resource, and if Inspec can get any resource, then we can put any assertion as well, right? So few common cloud service providers are like AWS, Azure, Google Cloud, that are supported by Inspec. And even you can check the official GitHub page also for the Inspec test for AWS. And this is really well written. You can go through the README and all. So, so how Inspec basically can access all the APIs of AWS resources that are remote resources. So it's like if I have created the AWS resource with my login credential, can you access that on your local machine? No, because you will have to set up the AWS credentials also on your local machine so that you can access all these resources. That resource can be like your any remote machine, any load balancer, or any storage, anything. So they have provided simple steps to set up the environment variables and set up the configurations file so that you can access any resource from your local machine or from any machine to a remote resources. So for the demo purpose, I have created a resource in the AWS that is a simple machine. We call it EC2 machine in the AWS. So it's a simple machine that has some processor, memory, hard disk, all these things, and it has some networking component, VPC, subnet. You can see I have created directly from the AWS console. You can also try. You just need to log into AWS console and you can create any resource. So these resources you can create even free of cost. They don't charge for minimal work. So this simple machine I have created for the demo purpose, and you can see this machine instance status is running, and it has some networking component. It has some AMI, that is image, and in the security you can see it is accepting the traffic for port number 22 and not any other port, right? So all this configuration, how can you test that using Inspec? We have mentioned few steps in the README also for AWS test. You can go through that. It will contain all the configuration steps and commands to run. So let's say common, very basic test for AWS. So let's say I have created a AWS EC2 machine that is just a normal machine like with some hard disk and process, and I want to see like whether this instance is exist or not, it is running or not. So for that, you can just create this basic test. Resource of the basic test is AWS EC2 instance. So this resource is provided by Inspec, and you cannot use any other resource here. So this resource is hard coded, and based on your test you can put the assertion. So on line number 2 and 3 you can see two tests. This is first test and second is below that, and we will run this test and you will see how many tests pass or fail. And instance ID, I'm using the same instance ID that we have created here. At the end you can see 3E4. Yeah, 3E4. So we can run this test easily. Okay, let me show in the terminal. So tests are in test directory under AWS test. Few sample tests we have created. Basic test is easy to test. And how can we run this test? So the command like same we mentioned in the README. So here you have to just give inspect, execute, and then the target. Target is important so that Inspec know which API it has to call. If you use AWS target, then it will use the AWS API. If you use Docker, then it will use the Docker API. And then you have to give the reason where this remote machine is created. So for me, I have used the reason like Mumbai, this code is AP South 1. Okay, so I'm using just same thing so that it will help Inspec to figure out which API and which parameters they need to use in the API for AWS. And then the test file name ec2 test.rb, and this default is just the profile. This is just for the configuration settings in my local machine. I will show you that also. So let's say if I run this command for the testing, to run this test, I mean. Yeah, so you can see this EC2 instance exists and it is running. So there are two tests. Okay, so next test can be like another in terms of security, or let's say you are accepting the traffic only on the port 22 and not on any other port. So you can write some positive and negative test around that also. Like here I have written it should allow the allow the traffic in means like inbound traffic through the port number 22. Let's say if I change port 23 or like let's say port 80, then what happened? This test is pass or failed. Let's see. What is the test name? AWS security group test. Okay, so I will just change the test name here, AWS security group. So here you will see one test failed because the port 80 is, we are not listening to port 80. And this is quite important from security point of view also, because you should not listen to various other ports. Attacker can use these ports. So you can write positive and negative test around those AWS resources. So another test can be, let's say you have a VPN and you should have some VPN, whatever the ID you are using, whatever the security group you are using, you can write test around that also. So basically, in short, whatever you see on the screen for all the configurations of your any resource, against those configuration, you can write your own test, because Inspec is basically using the AWS APIs. I hope it is clear. So if you take the pull for this Git repo, you will see all the examples. I guess I don't need to cover everything, but these are few basic example. And it's not like you have to use the instance ID also only. So you can use the instance name also. A lot of resources are provided by Inspec for AWS. Yeah, this is the official page, and if you scroll, so these are the resources. You can see a long list of resources for even AWS only, and similarly for Azure, Google Cloud also you can see those kind of list. So now next question is when to run this test. So what Shalika mentioned, like the test around Docker container file system, even you can run on your local machine also, like because you will just make the container up and you will run those tests, right? But these type of test like that we are running for the AWS resources, your resource should be up. Like for me, there was already a machine, EC2 one machine that was up and running, and I was just testing that. So for few type of test, you will have to first make your infrastructure up and running, and then you will run the test. And for few other type of test, even you can run on your local or before the infrastructure spin up. So it depends which type of testing you are doing. I hope it's clear when to run the test. Yeah, these are few basic examples that we just covered. So based on your project, you can take any example or any, I mean, you for your own practice or hands-on, you can create the resources on any cloud service provider. They provide free resources for few days or depends on your need. Thank you. So next is Azure part, infrastructure testing using Azure, that will be covered by Mohit and Ayushi. Mohit, Ayushi, over to you.
Yeah. Thank you, Lovely.
And before that, do we need any 2 minute break, people? Please put in the chat if you are feeling tired, or even we can take a 2 minute break. That would be better. And people, meanwhile, can ask question in the Q&A also if they're interested. So let's meet at 5:13. It's around 5:11 now. After 2 or 3 minutes, we can start. But feel free to put any question in Q&A. Meanwhile, Ayushi, you can share your screen.
Yeah, sure. Lovely. I hope my screen is visible and my voice is loud and clear to all.
Yes.
Okay. So, people, it's 5:13. Let's start with the Azure world. So, prior to that, my name is Ayushi, and I'm working in ThoughtWorks as a quality consultant. So, before we get into the Azure world, let's have a poll to check that how many of us are using the Azure libraries, or we are testing the Azure configurations in our day-to-day projects. So please, I would request you to please answer the poll. I'm just launching it. Okay. I'll just wait 10 seconds more. Okay. So I'm just ending the poll now, and I can see that most of the people are not doing this yet. So, okay, let's start with the Azure testing. So, though every cloud provider has their own libraries to test, but we have taken the example of the Azure over here. So though we'll be having a detailed discussion about what Azure SDKs actually are, but I'll just give you a brief introduction about it. Azure SDKs are the collection of libraries, and which makes the use of the Azure services much more easier for us. So using the Azure libraries, we just not only test the Azure services, but we can update, create, or delete the resources as per our choice, and even with the language of our choice. So we are not restricted with the language when we are talking about the Azure SDKs. So in the future slides, we will be focusing on how we can test the infra prior to deployment of any application, so that we can just avoid the unexpected deployment failures due to infra, and ultimately which will refrain us from losing the valuable business hours. I hope you must be thinking that right now we have talked about the Inspec. So now why we are switching to the Azure SDKs. So we will, it just depends on the project to project need. So we'll discuss, we have already had a discussion about the Inspec. Now we'll discuss about the Azure. Then we can just have a difference or the similarities opinion in our mind. And on the basis of that, we can choose that with which tool we want to go in future. So coming to the slides, what we're going to talk about in the upcoming slides. So first of all, just to be on the same page, just to have the same understanding of the Azure portal, we'll have a basic walkthrough of all the Azure components which are present on the Azure portal, like resource groups, VMs, storage accounts, vaults. We'll have an introduction about it. Then we'll start with the Azure SDKs, that what are Azure SDKs, how I can create, delete, and use the infra on it. Then we'll see that how we can test the libraries, what all step needs to be followed to write those validation, and what all we can cover in those validation, like presence of a resource or properties of a resource. Then after that, we will deep dive into our framework, the tech stack we have used for the implementation, and how we have done the implementation. And as promised, after that, we will be able to get the difference or the opinion that what is the similarities and the differences between the Azure SDKs and when to use what. So Azure components. So basically, I'll start with the resources. What is a resource? So in Azure, a resource is an entity which is managed by the resource. It's a service which Azure is providing to us. Every thing on the Azure portal, whether it's a VM or a storage account or a key vault, they all are considered as the resource. And in upcoming slides, we'll talk about the resources which are being generally used in the day-to-day projects like VM storage accounts. So this is the resource. I'll go to the Azure portal to show that what all the resources are. So if you can see the Azure portal, key vault, storage accounts, and virtual machines, resource groups, these are the storage, these are the Azure services, or I would say the resources which Azure is providing to us. Then the next we have the storage groups. So prior to launching any resource in the Azure, we need to have a resource group. So we can just imagine resource group as a logical construct or a container in which all the resources are being grouped together, which belongs to the same environment or same life cycle, or we should say that same security concerns. As in suppose we have two environments in our for our application. One is the prod, another one is the QA, and we have separate resources for both the environments. So what we can do, we can just put the QA resources in the QA resource group and the prod resources in the prod resource group. By doing this, what this will make the maintenance, or I would say handling of the resources, much more easier. So if suppose I want to give the access to the prod resources, so I just not need to give the access separately for all the resources. I can just revoke the access. I can just give the access on the resource group level. This is how our things become much easier, and we can just do the things more quickly. So moving to the Azure portal, if I see, this is the resource group which we have on the Azure portal. So if I click on the resource group, this is the resource group. So just give it some time to get load. Okay, these are the resource group which we have already created. As you can see that we have created vodka prod, vodka UAT resource group. So creating a resource group is very simple. We just need to click on create, and then we need to give the subscription and the resource group, and then clicking on the review and the create button, our resource group will be up and running. So whenever we'll be creating any resource in the further slides, we will be needing our resource group to give the name. Back to the slide. Um, okay, virtual machines. So what are virtual machines? I think we all are aware of it normally, but let me give a gist about it. Virtual machine is a on-demand scalable resource in Azure, and it's a physical hardware. So in virtual machines, we don't need to have the physical hardware with us. We can just get the virtual machines on the Azure and perform our task. We don't need to buy it or maintain the physical hardware at our place. So, but keeping in view that we need to do the configurations, patching, installation by our own. Azure virtual machines are basically used in three different ways. First is the deployment and the test, applications in the cloud, and extended data centers. So in the development and the test, what we need to do, we can just have we can just have a virtual machine having the configuration which we want, and then we can just code on it for our application, and we can do the testing. Applications in the cloud, like we all know that the demand of the resources um, demand of the application keeps on decreasing and increasing. So on the basis of that demand, we can just get the resources up and running, and we can pay on for that basic hour for which we are using the resource. We don't need to pay more unnecessarily. And the last one is the extended data centers. So extended data centers are the virtual machines when we connect the our virtual machines to the organization's network, then that machine can be used as the extended data centers. So if we'll go to the Azure portal, this is the virtual machines we can have. Okay, so these all are the virtual machines we have up and running in our Azure account. And as you can see, the resource group. So this virtual machine belongs to this particular resource group. We have just provided the resource group while creating the resource. To create the virtual machine, we need to click on the add button, then virtual machine. And then what we need to provide is the virtual machine name, region, and the image, the kind of machine we want, username, password, and other stuff. And then we can just review and create the details. And in some seconds, we'll have a virtual machine up and running for our application. After the virtual machine, the next we have storage accounts. So why we need the storage account? Whenever we want to store anything on the cloud, we need a cloud service, or I would say we need a storage service. And we cannot have any storage service without a storage account on the Azure portal. Prior to deploy any storage service, we need to have a storage account, and for that we create the storage accounts. So Azure provides us around 4 kinds of these storages. One is the blob storage, we call it as container as well, queues, file system, and the tables. And these, why we use the storage account, because these are very secure and massively scalable resource. So what is the difference between all these storage accounts that Azure is providing to us? Blob storage is the kind of storage that stores the data in terms of the objects. That's why it is also called as the object storage. So it stores the unstructured data in the cloud, and that can be of any type, like text, binary document, media file, or application installer, anything we want. The next one is the queues we have. And as the name suggests, queue service follows the first in first out concept. When we use the multiple jobs that needs to be executed, they get listed in a queue, and then server picks them up one by one on its own pace and then execute them. So this is how queue as a source service is used over here. Then we have the file system. So there is a slight difference between the file system and the blob storage, and that difference is file system can be used as the extended storage in our own system. How? When we create the file system, we need to specify the name and the quota. Quota is nothing but the size of the file system we need. Once we, while we create the file system, we get 2 things. One is the password, another one is the directory link. And that directory link and that password can be directly consumed to extend that, to use that file system as an extended drive on our systems. So this is how file system can be used. We don't need to have any specific storage in our systems. We can just use the file system from the Azure. Then the last, we have the tables. Table give us the flexibility. How? It's a kind of NoSQL database, and using table is beneficial when we are not sure that what is the data structure change that gonna happen in the future. Suppose right now my application is accepting 3 kinds of fields: name, phone number, address, and in future I get one more, like suppose credit card. So if we were on the traditional system, what we have to do, that we need to change the backend, and we have to cater those changes to the backend, adding the column to the database and all. But with the tables, we don't need to specify all those stuff. We just enter the new data, and that will be handled automatically if we use this table storage service from the Azure. So if we'll go to the portal, this is the storage service we can have from the portal. And Okay, these are the 4 storage accounts we have created, and different kind of storage we have used in it. So to create the storage account, again we have to click on the create, and here we can just give the name of the storage and the resource group, uh, and then we need the most important thing while creating the storage account is the redundancy. Redundancy is the kind of backup of the storage we want to have. Azure provides the different ways to have the backup, like on the in the same area or in different area. So according to our need, we can choose that. Now if I go to the storage account, if I'll go to this storage account, so I'll show that these are the 4 storage we have already talked about: containers, file shares, tables, and the queues. If I create a file share, so on creating the file share, as I talked, that it will ask you the name and the quota, and this is how you can just use this file share as the extended system to your physical computer. um, Now we are done with the storage accounts. Now the key vaults. What are the key vaults? I think as the name is suggesting, key vaults are basically to manage the secrets and the passwords and the API keys in our application. So though there are many uses of the key vaults, but basically we have two major use. One is the centralization, another one is the protection. So what the protection provides us: when application needs a connection to the database, we need to have those connection strings. So it's not a good practice to give those connection strings in the code. So what we can do, we can use this key vault to give the connection strings, and our code will pick the connection strings from the key vaults directly. Similarly, what the centralization is giving, suppose some kind of keys are being utilized in the application at many places. So we don't need to save them at every place. We can have a centralized system in the key vault that provides the protection as well to the API keys and the passwords. And and our code can get those keys from the key vaults directly. So on the Azure portal, this is the key vault we have. These are the key vaults, and as you can see, every key vault is under some resource group. And key vault creation is also very simple like other resources. So we just need to give the key vault name region, and we can just have the key vault up and running in our system. Now what are Azure SDKs? So Mohit will walk you through the Azure SDKs and its implementation. Over to you, Mohit. I'm just stop sharing.
Thank you so much, Ayushi, for the wonderful walkthrough over the Azure resources. Now I'll start sharing my screen. Hope you all are seeing my screen and it's visible to everyone. All right. So, first of all, a very good evening to everyone. This is Mohit Kumar. I have been associated with ThoughtWorks from past 1.5 year as a QA consultant, and in total, I have around 4.5 years of experience as a QA. So from now, we'll specifically talk about Azure SDKs and how we can use these SDKs to write our test around the infrastructure we have built on the Azure. So first thing we want to know about Azure SDKs, what are they? What are they? So these are nothing but just the combination or collection of the libraries that are built to make it easy to use the Azure services. That actually means we can either create, update, or delete the resources on the Azure. So how this SDKs would be used for the testing? So we can even fetch the resources information or even the resources through these Azure SDKs. How? I'm going to explain in coming slides. So how we can use these Azure SDKs to write the test? Our first step here would be to choose the language of our choice. So Microsoft Azure SDK support multiple languages, and it has a very good documentation of all the languages and the SDKs. So as you can see, we can use Java, Python, or PHP, even the C++ or C Sharp. Now you want to know where the documentation resides on the Azure. So I'll just take you to the documentation part, and where you can see all the links to all the SDKs for the corresponding languages. So it's just the Microsoft Azure site. You just need to go into the product section, and then on the download section, you'll get a list of all the SDKs present, and you can get the SDK, even read the documentation, and also get the GitHub repo. So in the documentation, you will get to know how and where the resources code has been reside. Through this, while you will be writing the test around the infra, through referring this documentation would be very, very helpful for you. Coming back to the slides. So how this would be helpful for us? The first advantage, you can even integrate these infra tests with the test automation framework our QA friends are already maintaining. Because it supports multiple language, we can do this. Also, if you are using infrastructure as a code, then you can also integrate these tests with the same repository or project where your infrastructure code is written. This is kind of one of the advantage we have using Azure SDKs. Moving on further, in the coming slides, I'll be explaining a framework where we have used this tech stack. So normally a QA analyst or most of our QA friends use Java with Cucumber, as Cucumber is helpful for the BDD framework. We do JUnit. We use JUnit to the for the assertions, and the Maven to get the dependencies for the different libraries. So before moving on to further things, I just want to know how many of you already know about Cucumber and the BDD frameworks. I'll just launch a poll. Here it goes. Please let me know how many of you are aware about Cucumber and BDD. 2 more seconds. Cool. I can see that 65% of people are already aware. That means it would be fun in telling you that, and those who don't know about Cucumber, well, you'll get to know, and that would actually motivate you to use Cucumber in your projects. Now, the first thing, where you can import, from where you can import these libraries. So this is the dependency for the Maven. You just need to add this dependency into the pom.xml and the Maven structure, and here you are ready to use all the libraries or classes that are present in the Azure SDKs. Moving on, the first question that arises in our mind is that how we'll authenticate in that test to the Azure portal. So before moving on to that, we just need to understand few terminologies that would be required when you are authenticating through the test or by writing the code. I'll just take you to the Azure portal. So first thing, subscription. It's the same thing, the subscription that you got on Prime or for the Netflix. And then the tenant ID. So tenant ID is actually for your organization. Your organization must be a tenant, and this tenant ID you can use when you are authenticating. Then I'll explain the client ID and client secret on the Azure portal. So here is the Azure portal. To see the tenant ID from where you can get or copy the ID, you just need to go to the Azure Active Directory. Here, as you can see, the Active Directory is from ThoughtWorks. So similarly for you, the Active Directory is from your organization, and there you can copy the tenant ID from here. To see the subscription ID, you just need to go to the subscription resource, and there you can copy this subscription ID. For the tenants, you again need to go to the Azure Active Directory. So for the client ID and for the client secret, you just need to create one application here. How we can create? Just go to the app registration, click on the new registration, and you will register one app here. and then you are ready to use all the resources on the Azure. Here, as you can see, it's the application already been created by myself, and where you can find the client ID and client secret. Here you need to go into the certificates and secrets, and there create a new client secret, and here you go, you will get the value and the ID. You just need to copy them to use them in your testing framework. Moving back to the PPT. So now we have subscription ID, tenant ID, client ID, and client secret. How to write code in Java for to authenticate. So here I have just declared one method called Azure authentication, where in try catch block I have used application token credentials class and created one object through it called credentials. And here I have provided client ID, tenant ID, and client secret into the constructor of application token class. Moving on, I have declared one more object of Azure, and using that I have configured with the log level. Here I have provided log level as none. You can use according to your need. It could be kind of log level dot basic, where you'll get the logs directly from the Azure when you are executing or fetching the resources from the Azure. And now in the authenticate method, you just need to provide the credentials you created here as an argument, and then the subscription ID. So as you can see here, this subscription ID is coming from the property file we are maintaining in the framework that I'm going to explain while explaining the framework. So if anything happens bad in this will get caught up in the catch section, and this will get printed on your screen. Moving on further, our third step would be how and what are the scenarios we need to write. So first of all, when there are resources on the Azure portal, we just want to check if they are seriously there through the test. So first thing is we need to check the existence of the resources, and then the properties of the resources. Like I already told you about Cucumber, so we have written some scenarios around the resources. As you can see in the first one, it's related to the virtual machine. As Ayushi have already told you about the resource group, that resource group contains the resources we have created on Azure. So first of all, I want to fetch all the VMs under a specific resource group, and then I'll validate that our specific virtual machine is present in that list or not. Then after confirming that our virtual machine exists, I want to validate these properties. I have taken just some examples. You can broaden that limit in the property section. Here I would be validating operating system that I have configured for virtual machine on Azure, public IP address, private IP address, and the size. Similarly, for the storage account, I'll just get all the storage accounts from a particular resource group, and then validate that our specific storage account is there or not. And then, like Ayushi said, the storage account contains tables and containers also. So here I'm validating if some particular containers are there in the storage account or not. Moving on to the implementation, I'll just take you to the code we have written. Here is the structure. Let me just give you a quick walkthrough over the structure we are maintaining. So this is the Maven structure you might have seen in your previous projects also. We have an SRC folder where main and test folders reside. In the test folder, we generally write the scenarios, and the logic behind those scenarios are written in the main folder. So in the test folder, I have one folder called resources, where are all the feature files are written. Feature files actually tells us the scenario that we are testing. I have already told you about the virtual machine scenario and the storage account scenario. Similarly, I have written some tests for the keywords. All right, so for the keywords, like I already told you, we are capturing all the keywords from a resource group and then validating that specific keyword is present or not. Then checking the properties of the keyword. So we can test the tags related to it. And then if soft delete for that keyword is enabled or not, and purge protection is disabled or not. So what are these? Soft delete enabled and purge protection disabled. I'm telling you because this is very important check for the keywords. So soft delete is something that helps you to recover a deleted state of a vault or a secret under a key vault. And purge protection tells you when you have purge protection enabled, you cannot delete the already deleted state of a vault. So if this is disabled, one can easily completely or hard delete the secrets or vaults you have. So that makes it very necessary to test these kind of configurations. Now, how the logic behind these feature files are written. So as you can see, every feature file has a corresponding step definition. That means these are the steps, and there is some logic behind these steps that are written in the step definition. So these are the step definitions under the folder. For virtual machine, this is the step definition, or you can maybe just click on these scenarios and go to the step definition. Here the logic resides, but where we are pulling the information from the SDKs, that resides in the main folder. If I'll just open that, and the Java, we have one folder called components, where, as you can see, authentication is written, code for virtual machine is there, and similarly for storage account and key vaults. So how feature files, step definitions, and the components are connected to each other. So feature file calls this step definition, and this step definition calls these components or methods that resides in these components. Starting with one basic scenario here, like as you can see, I want to capture all the VMs under a specific resource group. If I'll go into this implementation, this is the step, and I am getting the resource group as an argument here. Now I am just fetching virtual machines object. That means this classes objects, as you can see here. And through this object, I want to call one method called get all virtual machine, where I am providing resource group as an argument. Now we'll go into this. So the method has got opened that resides in the virtual machine class. Here I am using the Azure object we created while authenticating, and through this object we are fetching virtual machines and listing down all those virtual machines by the resource group. So it would return a list of virtual machine for a specific resource group. I can even show you how this works. Azure dot virtual machine dot list by resource group, and here we can provide the resource group. You can explore other classes as well when you will be using this. Coming back to the scenario, our next scenario is to validate that this particular virtual machine is present in that list or not. So we have already fetched one list where all the VMs are present. So here I'll go to the step definition. I am just iterating through that list and checking if that specific virtual machine is present or not. So I've used for loop. Here, this is our list from where I am just going into the particular index and checking what's the name that resides into it, and then validating that it's equal to virtual machine we have or not. And similarly, if it comes out as true, then this is the variable that has been declared as false, and this becomes true. And this is how we can validate that the virtual machine is present or not. This assertion statement actually validates that. So this is assert equals, that is validating that the VM present variable, Boolean variable, is true or not. If it comes as false, then the test would get failed. So I'll just quickly run the test for you. To run the test, we have a runner class that is having the folder to the step definitions and the feature files, and we need to provide which test we want to test. This is the tag, and tags are generally mentioned in the scenarios. These are the tags corresponding to every scenario. We just need to put this tag here, and we just need to run this class. So here I have put one tag that is corresponding to all the feature files. I'll just run quickly the test. Now, as you can see, it ran for key vaults, then storage account, and then for virtual machines. So taking example of virtual machine, as you can see here, it has picked OS name, operating systems name, public IP address, and the private IP address, and OS size also. This is how it has validated. Now again, go to the Azure portal. As you can see, the virtual machine I was talking about is here. This is the configuration, and the OS that has been picked up is given here, and the size is given here, and the public IP address and the private IP address has given here. So you can also pull other informations as well for a virtual machine according to your project's need. I mean, how important it would be for you to test. So you can pull these all the configurations to the Azure SDKs. Meanwhile, if you have any questions, you can keep on asking the questions in the Q&A, and our panelists would be continuously answering those questions.
And please raise your hand if you want to ask, like if you want to speak.
Yes, sure. Going back to the tests, taking one more example for the configuration testing. So as you can see here, we are testing the properties. How we are testing here? Just going into the step definition. As you can see, we have got the virtual machine name as one of the argument, and then the properties are configured in the map as a key value pair. So we'll just iterate through this map, and then here I have applied the switch case, where it would be checking that property is equal to the case we have provided. If the property is equal to operating system, then this code will run. If the property is equal to public IP address, then this code will run. So for the public IP address here, I have declared one string called public IP address, and then calling the virtual machine components object, which is get public IP address. This method actually resides here in the virtual machine component, and it wants the resource group name and the virtual machine name. And then we just need to call out Azure object and the virtual machine, then specifying which virtual machine we want to use by get by resource group. We just providing resource group and the virtual machine, and we have got our specific virtual machine. Now just calling out one method called get primary public IP address, and there the IP address. This will bring the IP address, the public IP address from the Azure, and will return you on this method's call. Coming back to the step definition, similarly you can do you can test the other configuration as well, like private IP address and the size. And in the time, if you are not able to find where the configuration reside in the Azure SDKs, you can always refer the documentation that has been provided by Azure. So there was one more advantage of using those Azure SDKs, which is you can even create, update, and delete the resources. So in so many cases, you want to create one kind of a storage account to check if the data is there or not, or the data is coming to that storage account or not. So these kind of scenario, if you have these kind of scenarios, you can even create one kind of resource while executing these tests. How we can do that? Let me just explain using the storage account. So I'll just go into the storage account class. Here I have mentioned one void main method so that we can quickly run the test, run the creation of the storage account. How we can do that? I have just given one kind of resource group, then the storage account. I'll just call out the object and then the storage account method. Here, like I already said that I want to create one storage account, so I am using define method. In the define, I'll just need to put the storage account name. Suppose I've given one name here. Now the reason, we just need to mention the reason. I'll just copy this one. So while you will be creating these storage accounts or the resources on the Azure UI, you will just need to put the same information as you are giving here. Going into it, it would ask you if you want to create the storage account with the existing resource group or you want to create a new one. Here I am using the existing resource group, providing the resource group name here, and then with access from all networks, or I could just create it directly. Just remove this code and then we'll run this. Right, now we'll go to the Azure portal and check if this has been created or not. So I'll just go to the resource groups. This was the resource group I mentioned. And then just give me a second. Again, going to the home and then directly onto the storage accounts. So let's check the test if they are running or not. It should be there. It might be taking some time. Yes. So here, as you can see, we have got the storage account that we created through the code. And this is how we can create other resources as well. All right. Coming back to the code. So I have explained almost every part. So you might be having one question that where our credentials would reside in our framework. So there is a resource folder into the main folder where config property file is there, and we have provided the configuration like tenant ID and subscription ID here, and pulling these through the config reader class we have declared here. Similarly, you can also use do scripts as well, because we you don't want to upload the credentials to the GitHub or any other kind of version control system. So you can use a do script that would directly fetch the links or the subscription ID and the tenant ID directly from the Azure. So that's it. And from now, maybe Ayushi can tell you about the the inspect and the Azure SDKs comparison, which would be helpful for you to choosing which should be used in your projects. I'll just stop sharing and maybe here Ayushi
Okay.
can
Thank
proceed.
you, Mohit. I'll
Yep.
just share my screen. Okay. So, so I hope we have gotten idea of when to use what. So I'll just start with the properties. The first one is the multiple language support. As we have seen that Inspec doesn't provide that support, but Azure SDKs, we are not dependent on the language we're gonna use. We can just use the language with our comfort level, whether it's Java or Python, whatsoever you want to use as per your project need. You can just go ahead and use it. No need to maintain the separate repo. This is the win-win situation for both Inspec as well as the Azure. We just don't need to maintain a separate repo for this infra testing. We can include the infra testing code with our application code in the same repo. Then create, update, delete infra dynamically. As Mohit has already shown that using the Azure SDKs, we can just create the infra or even delete it. So Inspec doesn't provide that flexibility. If anybody's project demands to create the infra dynamically to test or for any other reason, then the Azure SDKs is a better choice, because you can just do that with the code with the one click. You just don't need to go to the portal and do that again and again manually. So here the we'll give a 1 point to the Azure. Then coming to the Cucumber library support, and again, Inspec and Azure both supports the BDD framework using the Cucumber. So there is no restriction on this basis. We can use any one of them. Documentation support for both is nice. We'll share the link of the document support for both as well. So Inspec and the Azure both have good documentation support. Testing against the multiple cloud providers. As Inspec is not dependent on any of the cloud provider, we can use Inspec to write the config testing code for any of the cloud provider service. But this flexibility is not provided by the Azure. Azure is just for the Azure SDKs is just for the services which we are using from the Azure portal. So on the basis of this difference or the similarities, we can just choose with which tool we can go. It's Inspec or the Azure. We have many more, but we have just focused on these two right now. So on the basis of your project need, you can just check that whichever suits you better, and you can explore